So let's look at some examples of verifying identities. We'll start off with a relatively simple one here. We've got sine x times cosecant x. Now it helps if you have your basic identities memorized, because if that's the case, then certain things will kind of jump out at you. You don't want to have to kind of look through your notes every time. You want to just notice some things. Like here, you notice that cosecant is 1 over sine. So remember the procedure. We start with the most complex side, and we just start making substitutions or performing operations. Whatever we need to do to get that complex side to looking like the other side. So for example here, sine x cosecant x, I want to show that that's equal to 1. Well, if I notice that cosecant is 1 over sine, well, it falls right out. That's equal to 1. And there, yeah, we verified that identity. That's kind of a straightforward identity. It's almost the definition, right, of these reciprocals. Now, down here we've got one a little more complicated. So what I want to do is I want to take the most complicated looking side. And I want to show that that's just, in fact, secant. Well, I'm looking at this, and I'm just stuck here. I don't know what to do. Well, when you get to that point, one strategy is just convert everything to sine and cosine. So that means I'm going to convert that tangent to sine over cosine. So here we go. We've got cosine x plus sine x times sine over cosine. Okay, there. Now, we've made that substitution. Now we back up and say, okay, now what? Well, you look for operations that you can do, mathematical operations. And one operation that I see here is I can get a common denominator and add these. So this one needs a cosine on the bottom. See, the denominator here is cosine. So I need a cosine on top and the bottom. So I've got cosine squared x over cosine x. See, multiplying top and the bottom by cosine, plus sine squared x over cosine x. Okay? Now, I've got the same denominator, so I can put these together. I've got cosine squared x plus sine squared x. Ah, I like that. All over cosine x. Well, cosine squared x plus sine squared x is 1. So we have 1 over cosine x. Well, that is just secant x. So there. That's what we wanted to do. We wanted to show that this is equal to secant. Okay? Let's move on down to this one. Now I'm going to work with this side over here. So we've got secant squared x over tangent x. Okay, so once again, I'm kind of stuck there. But I just go to my default. I say, well, I'm going to write this as 1 over cosine, sorry about that, cosine squared x, see? And then down here, I've got sine x over cosine x. So I just converted everything to sine and cosine, and I'm wanting to see, well, maybe that will help me in some way. If I can convert it to sine and cosine, maybe I'll have enough identities in terms of sine and cosine that will work. Well, I've made the conversion. Now I look for an operation. Well, I've got this, a compound fraction situation here. I've got numerator, denominator up top and on the bottom. So let me just multiply the top and the bottom by the common denominator, which is cosine squared x. Because I want to clear this out. I have, too many denominators. So up top, I just get 1. And on the bottom, I get sine x cosine x. See? Because this cosine divides one of them, this one. Well, look at this. 1 over, so this is 1 over cosine times 1 over sine. You know, if I just split this up, I can write it this way. Well, this is secant and this is cosecant. So that's what we wanted to show. This is secant x, cosecant x. And that's what we wanted to show. So that one's done. Okay, now we move on to another one here. Okay, we've got cosecant x minus sine x. And we want to show that it's equal to cosine x cotangent x. So, different approaches you could take. You just need to pick one side and work with it here. I think what I'll do on this one, maybe I will pick this side this time. And I want to show it's equal to this. So here I go. I've got cosine x cotangent x. Okay? Well, here I am. I'm stuck. So I'm going to rewrite cotangent as cosine over sine. Yeah, like that. And let me see what I've got now. I've got cosine squared x over sine x. Now, remember, okay, so I've gotten this point. I may not know where to go, but so I look over and I say, okay, where am I supposed to be going? I'm supposed to make this look like this. And one of the things I notice is there's a minus here. Well, there's no minus over here. I sure do need one, though. So I need to figure out how can I get a minus in there. Well, cosine squared x can be written as 1 minus sine squared x. Like that. Well, that's still not exactly what I want. It almost is, though. Because look, look what I can do. I can split this denominator up. I can split the numerator up, I should say. So I've got 1 over sine x minus sine squared x over sine x. Ah, that's the ticket because, look, this is 1 over sine. That's cosecant. This is sine squared over sine. That's just sine. Oh, look at that. We're done. So we started here and we went through this process and we ended up over here. We could have started with this side and, made it look like this side, but I just wanted to start with cosine cotangent. Okay, now let's look down here at this one. We want to verify this identity. Now, when you first look at this, this looks rather complicated. How in the world are we supposed to do that? Well, I'm just going to pick a side here. I'm going to pick tangent x minus 1 over tangent x plus 1. Now, I look and determine what is it I want to do. I want to change this to this. Well, I want to show that this and this are equal. Here's a problem. Over here, everything is in terms of cotangent. Over here, I've got tangents. So if I hope to make this look like this, I need to somehow replace these tangents with cotangents. Well, I can do that, right? Because tangent is 1 over cotangent. Okay, so I've got 1 over cotangent. Yeah, so that's a start. Now, at least I don't have these tangents. I have the cotangents. Now, when I have a situation like this with these extra denominators, let me just multiply through by them. So I'm going to multiply this by cotangent, and the cotangent divides out. Multiply this by cotangent. Okay, see, I just multiplied by cotangent here, and the cotangent divided out. Multiplied it here, and that's that. Now, the same on the bottom. Cotangent x times 1 over cotangent. Well, that's just 1 plus cotangent x. See, just to save space, I didn't show my work here, but I multiplied by cotangent x, cotangent x, cotangent x, and cotangent x. And I got to that point, and that's what I wanted to show.